We're looking at the second part of our trigonometry unit. This is lesson 3.1, exploring side angle relationships in acute triangles. So with your graphing calculators, the biggest thing is you need to make sure that you are in degree mode. So in your graphing calculators, all of you should be going into mode, and you're going to scroll down until you see radians, and then you have to go to the right where you see degrees and press enter. Okay, so select degrees and then that should work. So at the very top, if you have a TI-84 Plus, it should say degrees at the very top here. So that's a good sign. If you don't, you can always do tan 45 as a test to see if it equals 1. So for this whole unit, this whole second part of this unit, you need to make sure that you are in the right mode, which is in degree mode. Okay, so again, you press mode, make sure you highlight degrees and press enter. Okay, so just some review stuff from 10C. We'll start with some review and then we'll go on to some newer concepts. So you need to remember Pythagorean theorem is always a squared plus b squared equals c squared. C always needs to be your hypotenuse, which is the longest side on your triangle. Okay, so the longest side is always going to be opposite to that 90-degree angle. So it's the longest kind of slanted line that we look at. Okay, so for example, they're giving us a triangle here with x, y, z. We have that the legs are 12 and 6, but we don't have the hypotenuse. So the reason we know that that's the hypotenuse is, one, it's kind of like directly across. If you were to cut that angle in half, that 90-degree angle, it's going to lead you to that hypotenuse. Also, it is the longest side. Okay, so you should always find that your legs, your 12 and 6, create an L shape, and then the hypotenuse always connects them. So we're going to label what we have, and we're going to solve for the missing side. So we have 12, which is your A, and B, which is your 6. You can actually interchange them and it wouldn't matter. So you could have 12 as B and A as 6. But what we don't know is the hypotenuse. So if I wanted to find your x to z side, you'd have to go a squared plus b squared equals c squared. A is 12 and b is 6. And you need to solve for c by isolating for it. So in my calculator, I would do 144. So I would do 12 squared in my calculator. And then 6 squared is 36. So I would get the answer in my calculator. I would add them together. So I just did 12 squared plus 6 squared. You can do it in one step like I'm doing right here. Once you get the answer, you need to remind yourself that this is not the actual hypotenuse. In order to get the hypotenuse, you do have to square root that answer to get c by itself. Okay, so in order to get your longest side, always remember to square root. Always to get the missing side from Pythagorean theorem, square root the answer. Okay, so I'm just going to add the note in. So I have 180 on the left side. To get that c by itself, square root both sides. C equals, I'm going to round to the nearest tenth of 13.4 as my answer. Done. Okay, so if you haven't seen this before, there's an acronym that we use to remind ourselves of how to use or find missing sides or missing angles, if it's a right triangle only. So with the stuff that I'm showing you right now, the Pythagorean theorem and for SOHCAHTOA, it needs to be a right triangle. So they have to have a 90-degree angle for these to work. Okay, if it's not a 90-degree angle, then you can't use these. You can't use Pythagorean theorem and you can't use SOHCAHTOA. SOHCAHTOA is just a short way of saying sine theta, which is your angle, sine of your angle, is always equal to the opposite side of the angle divided by the hypotenuse of that triangle. Ka is cos of your angle that you're looking from is always equal to the adjacent side, that's what the A stands for, over your hypotenuse. And finally, TOA, which is tan of your angle, is equal to OA, which is the opposite side, over your adjacent side. Okay, so if you're looking from the angle, what's opposite to it will go in the opposite value, and adjacent just means right next to it. So for example, find angle K to the nearest degree. Okay, so they're asking for angle K. So what I'm going to do is set that as my theta, or the item that I'm trying to solve for. Okay, so what you need to do is always label your sides correctly. Your longest side, which is directly opposite, remember, directly if you were to like slice that angle in half and walk straight, that's always going to be across from your 90-degree angle. That's your hypotenuse, okay, your HYP. The angle right next to the one you're looking at. Do you see how one side is always your hypotenuse? The other side coming out of it is always going to be called your adjacent. Adjacent means what's right next to it. So right next to the angle that you're looking from, which is this right here, your adjacent side is 13. And then K, you're going to slice this. Oh my gosh, guys. Okay, so I'm slicing that angle in half and walking directly straight from it, and that's going to be called your opposite side. Okay, so imagine you were to walk directly from K straight. That's going to land you at your opposite side. So it's opposite to the angle you're looking from. So the biggest thing that you want to do is label your triangle correctly. So look at what we're given. We have 13, which is our adjacent side. We have 9. You need to use those numbers. So you need to use what's given, not this one. We don't have our hypotenuse, so there's no point in using anything that has an H, meaning hypotenuse for H. So I start by writing SOHCAHTOA. These ones are useless to me because it has an H in there and I don't have anything that can help me solve for that. Ka is also useless to me because it also has an H in that equation. So the one that I'm going to use to solve for this is TOA. So what you start by doing is you write tan of your angle is equal to your opposite side divided by your adjacent side. Tan of your angle, which we don't know, but we do know our opposite side is 9, and our adjacent side is 13. So what we need to do is we need to solve for our theta, which is our missing piece. That's what our angle is, angle K. So once we solve for that, we have our answer. So you should always have only one item missing if you use the right equation. So in order for us to get theta by itself, we're going to move this tan to the other side of the equation. And to do that, it actually, whenever it switches sides, it becomes tan inverse. Okay, so the opposite of tan is tan inverse, and I'll show you that there's a button for that. So tan inverse, and in brackets, it always depends on something. So it's always going to depend on your opposite over your adjacent side. So that goes in brackets. Once you get here, you're going to switch to your calculator. So in your calculator, you're going to look for the tan button. And above it, in blue, if you have a graphing calculator, it should say tan inverse. Okay, so tan inverse. So you're going to start by pressing second tan. So that should give you the tan inverse, and inside the bracket you're going to put the opposite divided by the adjacent side. And you should get this. Again, if you're not getting this, it's because your mode is not in degree mode. So you have to make sure that you are in degree mode for this to make sense. So tan inverse 9 divided by 13 gives me this, and I'm going to round to the nearest degree because that's what they want. So I'm going to round to, instead of 34, I'm going to round to 35 degrees because this 6 means you got to move this guy 1 up. So I wrote my answer down. 35 degrees is my final answer. Our next question says find PQ to the nearest tenth. So find PQ. So we don't know what this side is, but we need to label what it is in relation to the angle we're looking from. If they give you an angle, look from it. Never look from 90 degrees. So we're going to look from 67 degrees. Our hypotenuse is always the longest side, which is always across from your 90-degree angle. And then the other angle, or the other side that's right next to your angle, is always called your adjacent. The opposite is kind of what's left over. So it's however you want to label it, just make sure that this is what you have at the end. So what your strategy is depends on who you are. So sometimes if it helps to go directly from the angle you're looking from, that's always your opposite. Once you label your sides, we don't want this. We don't want the adjacent because I don't need to solve for it and I don't have any information about it yet. So it's useless. So when I have SOHCAHTOA, I need to make sure that the A is not there. No A, no A. Okay, so get rid of the ka and the toa because they have adjacent. So if you wanted the adjacent, you'd have to use those ones, but we don't. We want to use sine of our angle is equal to our opposite side over our hypotenuse. Sine, this one's different than the previous one because we actually are given an angle, so that's going to go into that theta spot. So instead of theta, which is that Greek symbol, you're going to put 67 degrees. Our opposite is unknown, so we can just leave it as OPP, opposite. So leave it as it is. The hypotenuse, we do know, is 10.4. So we're going to replace our hypotenuse with 10.4 instead. Now the goal of the question is to solve for my opposite, which is my PQ. In order for us to solve for that, we need to get it by itself. Okay, so for opposite to be by itself, we have to get rid of this, 10.4. Right now it's dividing, so the opposite is multiplication. So we're going to multiply our right side by 10.4, and what we do on the right side, we have to do on the right side. Sorry, what we do on the right side, we have to do on the left side. So we also have to multiply by 10.4 on the left. Okay, so that's your last step, is to get the opposite. You have to use your calculator and put this in exactly how you see it. So we're going to do 10.4 multiplied by sine 67 to get our opposite side. So in your calculators, you're in degree mode. You want to do 10.4 multiplied by sine 67 within the brackets. So sine, cosine, tan will always depend on something, so you need brackets around the value that you're putting. And you should be getting that your missing side PQ to the nearest tenth is 9.6. So I got 9.6, and that's going to be in centimeters because it does give us units. So round this to 9.6 because of the 7 right next to it. So I wrote my answer. So take a moment, copy that in, make sure you have all your notes filled in. So this is kind of reviewing 10C for you guys. So make sure that if you did miss a bunch of trigonometry that you're taking the time to review right now. Okay, so continuing on, same kind of stuff. When we are given an angle, look from it. So we're going to look from 65, and we're going to always try to label our hypotenuse first because that's the longest side, which is directly across. If you were to like slice M in half, that's going to take you directly to your hypotenuse if you were to walk through it. And then your adjacent side is always right next to your angle after you label your hypotenuse. And your opposite side is if you slice your angle in half that you're looking from, it should land on your opposite side. So make sure that your labeling is correct. So in this case, they want us to find JK. So we want to find JK, which is the hypotenuse. So that's what we don't know. What we don't care about in this situation is the adjacent side because one, there's no number given and we don't need to solve for it. So you can ignore adjacent. So, ka, toa. I'm going to ignore ka because it has an A in it, and I'm going to ignore toa because it has an A in it and I don't care for it. I don't have a number there and I don't want to solve for it. So let's use sine again. Sine is always equal to the opposite side divided by the hypotenuse. Now let's fill it in. We know that the angle we're looking from is 65 degrees. We know the opposite is 7.6, and the hypotenuse is not given, so I just leave it as HYP. Okay, so there's a trick to this one that I'm going to show you because there are different strategies to do this that we will actually be using eventually, but right now there is a trick that you can quickly do that will save you a lot of time. This is at the bottom of the fraction. We're never allowed to solve for something at the bottom. We have to move it out of the way. And a quick way of doing that is swapping these items. If you swap what's on the left with what you're trying to solve for, it will do it in one step for you and you'll be able to calculate it way quicker than any other method. Okay, so what happens is if you ever wanted something like an x or a variable that's at the bottom of the fraction and you only have one item on the left, you can swap their location. So that means the hypotenuse is now on the left, 7.6 stays where it is, then sine 65 goes to the bottom where your hypotenuse used to be. This is 65 degrees. So where your sine 65 is, a hypotenuse goes there, and where your hypotenuse was, sine 65 kind of replaces it. So it's a quick little swap if you remember this, and that helps you solve it because now I can put this into my calculator and get the answer super quickly. 7.6 divided by, in your calculator, sine 65. Your answer should be, to the nearest tenth, your hypotenuse is going to be 8.4, and that's going to be in centimeters. So I round to one number after the decimal, which needs to go up because of the 8 right next to it. So 8.4 centimeters is your answer. Okay, so make sure you take a moment to copy this down, show your steps. So your final answer is 8.4 centimeters. In our next question, we're looking for angle M. So we're trying to solve for angle M. So that means you're looking from angle M and labeling your triangle with 8 being your hypotenuse, which is the longest side, and the next angle or the next side length is your adjacent, which is right next to the angle you're looking from. And we have NK or KN is your opposite to the angle you're looking from. So it tells us that we want to find M, which means that we need to use this and this because those are the only numbers given. You can't solve for an unknown angle if you don't have two sides. So I need 3 and I need 8 to be included. When I have SOHCAHTOA, I need to make sure the opposite is not part of it because I don't have the opposite side length. So I don't know what the opposite is, so I'm going to ignore SO, which is sine, and I'm going to ignore TOA, which is tan. So that leaves me with cos of an angle that you're looking from, that's going to be M, is equal to your adjacent side over your hypotenuse. Now we know those numbers. We know that the adjacent is 3 and the hypotenuse, which is the longest side, is 8. Now we need to get that Greek letter, which is theta, by itself. We need to get this theta alone. So in order for that to happen, you have to bring cos to the other side of the equation. And for that to work, you have to always change it to cos inverse. So the opposite of cos is cos inverse. So when you bring it over, it changes to that. So you're going to do cos inverse of 3 over 8 within brackets. Okay, so in your calculators, as long as you're in degree mode, you want to press second cos. Second cos. Okay, so I'm just going to clear this, second cos. And in brackets, you want to do your adjacent side divided by your hypotenuse, which is 3 over 8. And you should round to the nearest degree, which is 68 degrees. So theta, which is m, is actually equal to 68 degrees. Okay, so copy that in. Make sure that your answer is clear. You show all your steps, all your work. Okay, so let's go on to proportional reasoning. So proportional reasoning is where you do cross multiply and divide methods. So what you need to remember about when you have two fractions that are equal to each other, in order to solve for the variable, you have to do cross multiplication. So what's going to happen is these two guys are going to go together, and then these two guys are going to go together to create like this X shape. Okay, so I'm going to use a color. I'm going to start with these two guys multiplying. So you're going to multiply those two that create the first line of your x. So x times 14 is 14x. Then you're going to put the equal sign. Now you're going to go to the other part of your x. So these two guys have to multiply together on the other side of your equation. So 7 times 5 is 35. Lastly, to solve for x, you always just need to divide. See, it's called cross multiplication and division method for a reason, because we cross multiplied, and then you always divide by the value in front of your variable. So your last step is to take your calculator, and these guys cross each other off. The 14s are gone. So 14 crosses off with 14, and 35 divided by 14 gives me 2.5. And that's my answer. Okay, so we make our X shape, we multiply them. One of the answers goes on the left, one of the answers goes on the right side of the equal sign, and then you always divide to get your variable by itself. So this is called proportional reasoning, or sometimes they call it like cross multiplication division method. So cross multiply and divide. Okay, next one here. First, we're going to multiply these two guys together, and then we're going to multiply the pinks together to create our X. So the orange is going to be 17 times 12. So I'm going to put that in your calculator. 17 times 12 is 204. So I multiplied the 17 times 12. Now I'm going to go for the pink or light purple, however you guys see it. 3 times A is 3A. So the variable or the number goes in front of the variable. Now we're at the multiplication step, or sorry, the division step. Whenever you do cross multiply, usually you have to divide afterwards. So you want to get A by itself by dividing both sides by 3. 204, you're going to divide by 3, and you're going to get 68 as your answer. Okay, so I did 204 divided by 3, and I got 68. Okay, remember we're going to multiply these guys together, and then we're going to multiply these two together. So start with the light purple, pink purple. So we're going to multiply 12 times 5. So 12 times 5 is 60. That goes to the left side of your equation. And P times 14 gives me 14P, which is going to go to the right side of your equation. So you did the light pink, and then you did the orange on the other side of the equation. Once you do this, always divide by the number in front of your variable. P should be left over, and in your calculator, you're doing 60 divided by 14, and I'm getting a decimal number of like 4.29 as my answer. Okay, so I'm just going to zoom back out so you guys can write this down if you didn't already. So multiplication, cross multiplication, multiply for the first one 14 times x, and then the 5 times 7, that's how I got the 35. Always divide by the number in front of your variable. The second one, I multiplied 17 times 12, and then the 3 times a on the other side, and divide by the 3, which is in front of your variable. And C is where I multiplied the 12 and 5 to get 60. And then I divided by the number in front of P, which was 14 to both sides. So that's how I got P by itself. Okay, so an acute triangle, if you're wondering or trying to remember what that means, is that all angles are less than 90 degrees. If all angles are less than 90 degrees within this triangle, then it's called an acute triangle. So all angles less than 90 degrees. That's kind of the definition for them. Okay, so let's go to example number 1. What we're doing here is we're comparing the side length to the opposite angle with sine. So sine of its angle opposite to it will be right on top of it. So these guys match up because they're opposites, and these guys would match up to be opposites. Once we have that equation, I'll show you how to set that up soon. This is actually called the sine law that is showing you the steps before we get to it. This is where we want to do that cross multiplication. So step 1, these guys multiply together, and then these two guys multiply together. So same procedure as above. Okay, so we're going to find the answer, but then I'll sketch the triangle that shows you where these are coming from. So what we want to do is multiply a times sine 70. That's the orange part. So a is going to go in front of sine 70 degrees. So a sine 70. That's going to go to the left side of the equation. The right side is going to be that purple, light purple. 30, which is a side length, or sorry, 13, which is your side length, is multiplying by sine of 30 degrees. So your angles are always kind of going in brackets if you use your calculators. Now, in order for us to get a by itself, we actually have to get the sine 70 to the other side. That's one item. This is kind of one grouping right here that we need to remove and bring to the other side to get rid or get that variable by itself. So you're going to divide both sides by sine 70 degrees. What you do on the left, you do to the right. So what that does is it crosses off that sine of the 70, leaving us with a, which is what we're trying to solve for. We're trying to solve for what is the side length for a. So now we just need to put this into your calculator exactly how you see it. So in your calculators, you should be putting in 13 sine of 30, close your bracket, divided by sine of 70. Okay, so I did the top divided by the bottom that I just wrote out. If you're in degree mode, you should get this answer for A, which is 6.9, because they do want the answer to the nearest tenth, which is one number after the decimal point. And that is our answer. We don't know the unit, so we can leave it as it is, so 6.9. Okay, so I'm going to sketch the triangle that's creating this. What's happening is you're going to draw just kind of like a triangle that's not a 90-degree angle triangle, not a right triangle. So this equation that we're using is going to work if it's not a right triangle, which is nice. It does actually work for 90-degree triangles as well, but we predominantly use it when we don't have a 90-degree angle, when we can't use like SOHCAHTOA anymore. Let's make this nicer. Okay, so they're telling us we have a side length A, and opposite to it should be what's underneath. Okay, so these guys are always going to be opposites to each other. These are going to be opposites to each other. So what they're saying is directly across from A, you're going to see a 30-degree angle. That's where that sine 30 came from. And then for 13, we have a side length of 13. And opposite to that, we're going to see a 70-degree angle, right? Because I'm looking at these two numbers in particular. I'm looking at those two numbers have to be opposites to each other. Those two have to be opposites of each other. That's what this relationship is representing, the opposite relationship. So angle to side length and angle to side length. And we now know that A is equal to 6.9, so we can fill that in. Okay, so that's what we've been given, and that's what we're kind of working with. Okay, so make sure that you have this copied in. This is going to help you for your assignment coming up. Okay, for the next one, we're going to start by sketching the triangle first and then representing that relationship. So they tell us that a side length of 20 is opposite to an angle of A. The angles are always attached to sine. So that's how I know that A is the actual angle and not the side length. And then I look at these two. 13 side length is opposite to 36 degrees when it comes to your angle. Okay, so I'm using those kind of opposite relationships. The sine is always attached to that angle. That's why I know to put them there. What they want us to do in this case is solve for angle A. So step one, we're going to use that equation that they've given us. We're going to do our cross multiplication divide. These guys go together and these two guys go together. So 20 is going to go in front of sine 36 because they're just multiplying. So I'm going to use my calculator eventually, but the number is just going in front like a coefficient. So 20 times sine 36, 20 sine 36. On the right side of the equation, I'm going to put 13 sine of A. So the number goes in front of your sine and your angle. Next, we need to get sine A by itself. You need to get this by itself. Isolate for sine A. Get it by itself. So in order for us to do that, we actually have to get rid of that 13 that's kind of glued to it right now. Whenever there's no symbols between them, that means that they're multiplying. So we need to divide both sides by 13. Divide this side by 13, divide the left side by 13. Those guys cross each other off. Now we have sine of A, and that's equal to all that stuff on the left, which we're going to use our calculators to evaluate. So use your calculators to get this answer. So I'm going to put 20 sine of 36 on my calculator, close the brackets for the angle, and you're going to divide that by 13. Okay, so that's going to give you what sine of A is. So that's going to be 0.904. I like to keep at least 3 decimal places when it comes to these answers. So whenever you're looking at a ratio, this is what the ratio is, you're going to get 0.904. Okay, so that's what I get for sine of A. Sine of A. Now, in order for us to actually get A, we have to get A by itself by moving that sine to the other side. So this is that step we've done before. This needs to move over. It's not allowed to stay where it is. So for us to have A by itself, we're going to have to do sine inverse whenever we move it over to the other side. And in brackets, it's whatever was on the left originally, so sine inverse of 0.904. So we're doing sine inverse of the left side. Now we just use our calculators. If you want to be super awesome and have the most accurate answer, I'm going to show you a little trick that you can do. So watch carefully. I'm going to do second sign, and then this answer is really, really accurate. It has much more decimal places than I originally had. But what you can do is drag that answer. So right above the negative sign, do you guys see how it says A and S? So right above the negative sign, you're going to put second negative sign. So second negative sign. So what that does is it drags your answer from the previous step down to that one, and then you find your answer. It's the same kind of as saying sine inverse of 0.904. We could have done that as well. Okay, you just get more accuracy. Do you see how like the one right above it is actually a slightly different? It's more accurate. So this one is more accurate than me having just the 3 decimal places for this one. Okay. But in the end, it does say round to the nearest degree, so they're both going to give us the same answer at the very end. So it's completely your choice which one you want to use. I just wanted to show you those 2 strategies. So A equals, to the nearest degree, it's going to be 65 degrees. So round to no decimal places, round up to 65. So I did this in my calculator, I got the answer, I rounded to the nearest degree, which is 65 degrees. Okay, so take a moment, copy this in, pause this video if you need to at any point. Okay, example number 3. Sketch a triangle for the following situation, then solve for the unknown side lengths. So we have to draw an acute triangle. We have 32 degrees is opposite to R. So I just make sure that they're opposites of each other. And 75 degrees, which is also given, is opposite to 13. So these guys are opposites to each other. Degrees should always be on the insides, right, the interiors, and those side lengths are kind of on the outsides, so the side lengths. So we already have the relationship done for us. We just have to do our cross multiplication and division. Those guys go together. And these 2 guys go together, changing up the colors. So 13, which I'm working on the orange right now, is going to multiply with sine 32 degrees in brackets. Then R is going to multiply by sine 75 degrees because that's the blues going together. So the blues are multiplying together. The variable can either go in front or at the back. I kind of like to keep sine of the angle at the ends always, so that way they don't get mixed and there's no kind of discrepancies there. Okay, we need to get R by itself. We always do the opposite to get R by itself. So by dividing both sides by sine 75 on both sides. So R needs to be alone. You get rid of that sine 75 by division on both sides. So divide, divide. So what that does is it leaves you with R by itself, and then we're going to put this whole thing, exactly how we see it, into our calculator to find R. So we're going to do 13 sine of 32 degrees divided by sine 75. So you're going to get that R is equal to 7.13. It doesn't tell you what to round to, so we can kind of leave it like that if we want to. And it doesn't say the units as well. So that's our final answer of 7.13. Okay, so I'll leave that there. I've drawn the triangle and I've solved for the unknown side length. So cross multiplication and division. Cross multiply and divide. Okay, so this is our last example. I want to show you how to set up that same equation using those equivalent ratios. Okay, so what you always want to look for are opposites. Remember, opposite relationships is what we want to use. These guys are opposites, so they're going to go on the same fraction, and these guys are opposites, so they're going to go on the same fraction. What you're missing should always go to the top. So since you're missing your angles, you want your angles to be at the top. So you're going to start by saying sine of my missing angle, which is Q, right? We don't know what angle Q is, divided by over its opposite side that we do know is 1.5. Okay, so I'm starting with sine of Q, which is the angle we don't know, over 1.5. And that's going to equal the blue sine of 50 degrees over 1.3. So the blues, you have to make sure that the tops are the same and the bottoms match up. So if you guys notice, I have the sines with the angles at the top of the fractions, and both equations or both fractions have the side lengths at the bottom of the equation. They have to line up. If they don't, you're not doing it properly. Okay, so now we're going to do our cross multiplication and division. So these guys go together, and then these can go together in any order, right? As long as you make sure that you cross multiply. So cross multiplication, the number goes in front of your sign. So I put 1.3 times sine Q. And then my orange is 1.5 times sine 50 degrees. So 1.5 times sine of 50 degrees. To get sine Q by itself, you kind of have to start with that. You can't just get rid of 1.3 sine. You have to actually get rid of the 1.3 first. So we're going to divide both sides by 1.3 to get rid of that so that we can have sine Q alone. So now we're going to use our calculators. We're going to put that into our calculator to find out what sine Q is equal to. So I'm going to go 1.5, sine on the right was 50, divided by the side length was at the bottom 1.3. So top divided by bottom equals, I get this 0.8839. So I have a few digits there. I have, or I could go like 884 if I want to. I keep 3 decimal places usually. So this one I just wrote 4 for some reason. Now, if you guys look at this question, remember we still need to find what Q is. Q needs to be by itself, which means that this sign has to go to the other side. And for Q to be alone, you have to do that sine inverse of the number that you just found. So sine inverse of 0.8839. So in my calculator, sine inverse is going to be second sine. And remember how I said that if you want really good accuracy, you're going to press second negative sign. That's going to drag your previous answer into this slot right here. So second negative sign gives you this much more accurate answer of, it does say round to the nearest angles. It says round to the nearest tenth. So we're going to round to 1 decimal place. So Q is equal to 62.1 degrees. This is an angle, so we need to make sure we include that degree symbol. So our final step over there is to make sure that we round our answer to one number after the decimal, which means tenth. This is tenth. So we got our answer. Now for our last question for today, for our lesson, we're going to solve for side length z. Okay, so we need to find z. So whenever you're looking for a side length, you put it at the top of your fraction. Okay, before we were looking for an angle, so we put the angle at the top with sine. So z is going to go at the top. Opposite to z is sine 82 degrees. So those guys are opposites to each other. These guys are opposites. So when I'm looking at the marker, those guys are opposites and these two guys are opposites. So purples, I did Z over sine 82 degrees since I'm trying to find out my missing side length. That's why I put it at the top, because you can switch. If you ever want a missing angle, put that at the top. If you want a missing side length, put that at the top. So whatever I'm trying to solve for, it switches, which is nice, as long as you line them up. On the other side, the fraction should have the side length for the orange at the top, which is 12, and the bottom should have the angle, which is always attached to sine. So 12 divided by sine 27 degrees, that's going to be the bottom of your fraction. So what's going to happen is these two guys are going to go together and these two guys are going to go together. So Z is going to multiply with sine of 27 degrees. And 12 multiplies with sine 82 degrees. So in order for us to get Z by itself, we need to divide both sides by the sine 27, which are attached to each other. So we have to bring them over in one step. So these guys are going to cross each other off. So Z by itself is, once we put in the calculator, we'll have our answer. Okay, so our final step is to put 12 sine of 82 degrees at the top of your fraction. So put that into your calculator, divided by sine of 27 in brackets. Okay, so I put the top divided by the bottom. That's going to give us Z, which is, this is going to be a side length, so it's going to be, we don't know the units, so we can just leave it as to the nearest tenth. They want us to round to the nearest tenth is 26.2 as our answer. 26.2. So this one has to move one up because of the 7 right next to it. So 26.2 is my final answer for this question. Done. Okay, so that is our final work. So what you should be working on is homework slash the assignment. So you want to work on the assignment questions. Questions, I believe 1 to 4 is what you can do so far after this lesson right here. Okay, so that's it, and work on the assignment. Have a nice day, guys. See you soon.